Hello again. In this video, I'm going to go over Objective 2 from section R5, which is about factoring by grouping. Now, factoring by grouping is a technique that we use sometimes when a polynomial contains four terms. Now, just because a polynomial contains four terms does not mean that factoring by grouping will necessarily work. It's only in special circumstances where you have a polynomial with four terms that factoring by grouping will actually work. Having said that, let's look at a couple examples where we can use factoring by grouping. Okay, so here notice that this expression has four terms in it, so it is a candidate for factoring by grouping. And let's see if factoring by grouping will work. And I think the only way you're going to tell is by trial and error. So here's the idea behind factoring by grouping. We're going to group two of these terms together and then group the other two terms together and then try to factor out what's in common with the first two terms and then try to factor out what's in common with the last two terms. So you could rearrange these in any way that you prefer in the hopes of getting it to work. Okay, so for now, let's just take these two first and then factor out what they have in common. And then we'll factor out what these two have in common next, and we'll see if it works, if factoring by grouping works in this case. Okay, so these two terms have a 2a in common, right? So I'm going to pull the 2a out. And when you pull the 2a out, you're left with x here, and then here you're left with minus 3 times y. And you can check that and make sure that's true by distributing. So 2ax would give you this term, and then 2a times 3y. Okay, so that would give you negative 6ay. Okay, so that looks like it's correct. And then you factor out what's in common with the last two terms. So in this case, they have a 5 in common. And when you pull a 5 out of there, you're left with the x. And when you pull a 5 out of here, you're left with a minus 3y. And this is when you'll know whether factoring by grouping will work. If these two are the same thing, then factoring by grouping will work, because then what we're going to do is we're going to factor this out of this expression. So notice, here you've got two terms, right? You have this term plus this term. They have something in common, right? X minus 3y. And so we're going to factor that x minus 3y out front. And when I yank it out of here, I'm left with 2a. And when I yank it out of here, I'm left with plus 5. Okay, so that's how this will factor. So factoring by grouping did work in this case. Okay, now if these were different, right, if this was different than this, then factoring by grouping, at least the way we've arranged it, would not have worked. So sometimes if that happens, what you do is you reorder this and you try a different pair. So you might move this one up here with this one and try factoring out an x. And you might take this one with this one and factor out like the 3y or the minus 3y. Okay, but the way we arranged it actually did work, so we don't need to redo this. Now, let me just say this before we move on to the next one. If you were to FOIL this out, notice that you would end up with these four different terms. So let's just check that. You would get, so first would be 2ax, which is that term. Outer would be 5x, which is this term. And then minus 3y times 2a, that's the inner part. That's actually negative 6ay, which is this term. And then the last would be negative 15y, which is that term. So these are the four terms that result from FOILing this out. But here's the issue. We're going backwards in a way, right? We're starting with the four terms here that you get from FOILing, and we're actually trying to get back to the the two terms, the two binomials that we had before we FOILed it out. And that can be difficult to figure out. So that's where this factoring by grouping is very helpful. If you factor by grouping, you can see what it looked like before you FOILed it. Okay, so let's try this one. Okay, so we do have 4 terms. So this is a candidate for factoring by grouping. And let's just try this arrangement and see if it works. It may not work, but maybe it does. If it doesn't, we'll try a different arrangement. So let's take these 2 terms and group them together and then factor out what they have in common. Well, the only thing they really have in common is a 1. So I guess if you wanted to factor out a 1, you could do that. Okay, and then we're going to group these together and factor out what they have in common, which is an m. So if you factor the m out, you're left with 3 minus n. But notice, these are not the same. And so this is not going to work. The way we've arranged it doesn't work. That's how you know it doesn't work. So let's try this again. So let's rearrange this in a different way. You can rewrite, when you add and subtract numbers, you can write it in different orders, right? And it'll still be the same. So what I'm going to do is maybe take m squared and then say minus mn. So I'm putting this up here. And then maybe minus 3n plus 3m. Okay, and then I'm going to group these 2 together and factor out what they have in common. So they have an m in common. And so when you factor an m out of here, you're left with m. And when you factor an m out of here, you're left with minus n. Okay, and now these appear to have a 3 in common. So let's pull a 3 out. And you're left with a minus n. And then you're left with an m. Now notice 3 times negative n is negative 3n, right? So if I pull a 3 out of this, I am left with a negative n. Now at first glance, these don't appear to be exactly the same, but they really are, because you can rearrange the order of this. The order doesn't matter here, so I'm going to rewrite that in a different order. Okay, so this is really, if you change the order, this is m, a positive m, and then minus n. So there's no reason you can't write it in that order. It's the same thing. Okay, so having done that, I think you can see now these are the same. And so it looks like factoring by grouping is going to work. So the next step is to factor that out, since it's in common with the first term and the second term. Okay, so let's factor that out. M minus n is going to be factored out. And it looks like you're left with m. M here, right? When you factor this out, you're left with m. And when you factor m minus n out, you're left with m here, right? And when you factor m minus n out of here, you're left with a 3. Okay? And so that's how this factors. Now again, you can check this by foiling it out and seeing if you get these 4 terms. So let's just check it and see. M times m would be m squared. So that's your first. Outer would be 3 times m, which is this term. Inner would be minus n times m, which is this term. So let me check these off. That was the first. This is the outer. The inner is this one. Now remember, the order doesn't matter. So minus n times m is the same as minus m times n. You're just rearranging the order of multiplication. And then the last would be minus n times 3, which is minus 3n. Okay, so if you FOIL this out, you will go back to these 4 terms. Okay, so these are a couple of good examples to illustrate how we use factoring by grouping to factor polynomials that happen to have 4 terms in them. Okay, now factoring by grouping only works if you have 4 terms, and like I said before, just because it has 4 terms doesn't necessarily mean it's going to work. And sometimes you have to rearrange the order in order to make it to work, like we did in part B. So just be aware of that. Okay, I hope you found this video helpful. Thank you for watching. Bye-bye.